Cold Open, a clean-looking code repository, a normal zip file, a helpful AI assistant, and a convenient connected app can all feel safe in isolation. But this week's security signal points to the same uncomfortable lesson: trust boundaries are moving. Developers are asking AI agents to read projects and run commands. Employees are opening files that match their daily work. Browsers hold sessions that can unlock enterprise systems. Apps request OAuth access that may outlive the task that justified it. The question for today is simple: how do you use automation without giving it a bigger blast radius than the humans it is supposed to help? Here is the central thesis. AI security is no longer only about model behavior. It is about the entire workflow around the model: repositories, local tools, browser sessions, cloud permissions, memory, connected apps, and security alerts. The organizations that win will not be the ones that automate every task first. They will be the ones that make automation narrow, observable, revocable, and boringly well-governed. The first story is the clearest example. Bleeping Computer reported that a clean GitHub repository could trick AI coding agents into running malware. We are keeping this at a defensive level. The important point is not a recipe for abuse. The important point is that modern coding agents often sit in the middle of an unusually sensitive workflow. They can read project files, summarize instructions, inspect dependencies, suggest terminal commands, and sometimes execute local tools. A repository is no longer just source code for a person to review. It may also become input to an automated operator. That changes the security model for developers. A project can contain ordinary files, documentation, configuration, scripts, issue templates, dependency metadata, or test instructions. If an agent treats all of that as trusted operational guidance, the project becomes a way to influence the agent. The safe response is not to ban tools. It is to separate trust levels. Untrusted project content should not be able to silently authorize shell commands, credential access, package installation, browser actions, or changes outside the workspace. Before an agent runs anything with side effects, it should show what it plans to do, why it believes the step is needed, and what files or systems will be touched. This is where Microsoft's AutoJack research fits the bigger picture. Microsoft described a web page-to-host risk pattern for AI agent environments under certain conditions. Again, we are not discussing operational details. The defensive takeaway is enough: an AI agent is a bridge. It can connect untrusted web content to local files, command tools, APIs, cloud resources, and developer credentials. Bridges are useful, but every bridge needs gates. Sandboxing, least privilege, explicit tool approval, network restrictions, action logs, and rollback paths are not advanced features. They are the foundation for agent safety. Now add AI memory. Microsoft's guidance on guarding AI memory highlights a second trust boundary: what an assistant remembers. Memory can make an assistant more useful because it can preserve preferences, project context, and recurring workflows. But unmanaged memory can also retain sensitive details, mix trusted and untrusted facts, or influence future actions invisibly. If an assistant remembers that a certain repository is safe, or that a certain approval pattern is normal, who wrote that memory? Was it a user? A document? A website? A malicious prompt hidden in content? Can the user inspect it, edit it, or delete it? The midpoint payoff is this: automation reduces risk only when its memory and permissions are narrower than the damage it could cause. If an agent can remember context, call tools, and act across systems, then memory writes and tool calls should be security events. They should have source attribution, retention limits, audit logs, and deletion controls. For enterprises, AI memory belongs in the same governance conversation as logs, databases, and identity systems. For developers, memory should not become a hidden configuration file that anyone on the internet can indirectly edit. The next two Microsoft stories show why this matters outside AI as well. Microsoft reported a PhotoZip campaign targeting the hospitality industry and delivering a Node.js implant for persistent access. The lure worked because it matched ordinary work. Hotels, venues, travel teams, and service desks handle photos, bookings, vendor documents, and customer requests. A message does not need to look strange if it arrives in the right business context. At a safe level, the intrusion path is familiar. A plausible file reaches a user. A foothold is created. Attackers then look for credentials, persistence, internal visibility, and ways to move deeper. The defensive lesson is layered. Email filtering helps, but it is not enough. Organizations need attachment detonation, endpoint detection, application control, identity alerts, restricted scripting environments, and a reporting culture where employees can flag suspicious files without fear. Most importantly, incident response should assume the first clicked file is only the beginning. The real question is what the attacker can reach next. Microsoft also analyzed StealthSea and Amadea, focusing on infostealers and the cybercrime services that deliver them. Infostealers are dangerous because they turn personal or endpoint compromise into enterprise compromise. A stolen password is bad. A stolen browser session, token, cookie, or synchronized profile can be worse because it may bypass parts of the normal login story. The attacker may not need to break into the front door if a stolen session already looks like an authenticated user. This connects directly to AI agents and connected apps. Modern work depends on browsers, SaaS dashboards, code repositories, cloud consoles, ticket systems, and identity providers. If credentials or sessions are exposed, automation can amplify the effect. An agent with access to a compromised environment may speed up both legitimate work and attacker movement. Defenses include phishing-resistant MFA where possible, conditional access, device compliance checks, session revocation, short-lived tokens, least privilege admin roles, and rapid credential rotation when exposure is suspected. Cloudflare's OAuth for All post brings another piece of the trust boundary puzzle. OAuth is generally better than shared passwords or long-lived static secrets, because users and administrators can grant scoped access and revoke it later. But OAuth is not magic. A connected app still represents delegated authority. It may read data, modify configuration, receive events, or act on behalf of a user. As more AI tools and automation platforms connect to cloud services, teams should ask 5 questions before approving access: what scope is requested, who owns the app, how long access lasts, how it can be revoked, and what logs show after it acts. Cloudflare's recent writing on defending against frontier cyber models also reinforces the speed problem. If attackers use AI to scale reconnaissance, phishing, vulnerability discovery, or social engineering, defenders need automation as well. But defensive automation must be scoped. A system that can block traffic, quarantine devices, revoke sessions, or disable accounts should have guardrails. A false positive at machine speed can become an outage. The target is not blind automation. The target is fast detection, human-readable context, safe defaults, and carefully controlled response actions. GitHub's work on reducing false positives in secret scanning may sound less dramatic, but it is one of the most important developer security lessons in today's briefing. Security tools spend human attention. Every noisy alert teaches developers to ignore the next one. Every accurate alert builds trust. Secret scanning becomes more effective when it can distinguish real exposures from harmless strings, explain what system is affected, show whether a credential appears active, and point to a clear rotation path. This matters for supply chain security because secrets are often the connective tissue between code and production systems. A leaked token can open package registries, cloud accounts, CI pipelines, databases, or internal tools. When scanning is precise, teams rotate faster. When it is noisy, exposed credentials linger. In the AI era, alert quality matters even more because agents may summarize, triage, or act on alerts. If the signal is bad, automation makes bad decisions faster. So what should builders, security leaders, and everyday users do next? First, treat AI coding agents as operators, not autocomplete. Give them narrow workspace permissions, review commands before execution, and block untrusted content from authorizing sensitive actions. Second, govern AI memory with visibility, source attribution, retention rules, and deletion. Third, reduce the value of stolen sessions with hardware-backed MFA, conditional access, token hygiene, and fast revocation. Fourth, review OAuth apps like production access, scope, owner, duration, revocation, and logs. Fifth, tune security alerts for trust, because developers will not fix what they no longer believe. The conclusion is straightforward. Automation is becoming part of the attack surface because automation now touches the systems that matter: code, identity, cloud, browsers, memory, and response workflows. Used well, it can make defenders faster and reduce repetitive mistakes. Used carelessly, it can give attackers a larger lever. The rule for the next wave is simple: do not ask whether an AI agent or connected app is smart enough. Ask whether its authority is limited enough, its actions are visible enough, and its access can be revoked before a small mistake becomes a major incident.